In this part of physics, we are going to talk mainly about 3 points. First point is reflection of light. Second point is plane mirrors and the properties of images on plane mirrors. Third one is refraction. Okay, number one here, as you see, what is reflection of light? Reflection of light, when a light moves in a straight lines, as we said that in optics, when it faces a boundary or a surface and it cannot go through that surface, that means it will be reflected back in different angles, or in the same angle of incident, it's going to be the same angle of reflection. In this case, we call this one what? Reflection. So reflection when the light faces a boundary or a wall or a surface that it cannot go through it. So it's reflected back to the other side. So in this case, we call this one reflection. And we have here two types mainly of reflection. If the plane or the surface is smooth or leveled like this one here, we call this one what? A specular reflection. And this specular reflection is the type of reflection that is responsible for producing images. So here now you can see images and they can produce what images. Other ones is for rough surfaces. When the surface is as like this, as you see, it's not smooth, it's not leveled. So this one is called diffuse reflection. Diffuse reflection, that means each ray of light will be reflected in different angle. So that means no one direction for the reflected lights, beams or lights. So that means each ray will come in different way. So that means it's hard to make what here images. So here we can't make images. So images are produced as the result of a specular what? Reflection. Okay, now when images are made and are reflected, we have a law of reflection of light that is exactly worked on this way. Here now, when light is going, when it is going into the surface, it goes with an angle, this angle now, which is angle of what? Of incident ray. So incident angle. This angle now, it's equal to the what? To the reflected what? Angle. So here now we have an imaginary line. This imaginary line is called what? The normal. And it is perpendicular. That means it makes 90 degrees with the what? With the plane. Whether is it mirror or whatever is the plane as. So here now, this normal is 90 degrees. Now the angle that is between the normal, and the incident ray of light, we call it incident angle. And the angle that is between the reflected ray and the normal, we call it what? Reflected angle R. So that means you can call this one theta I, and here theta what? R, or you give it any name, X or Y or whatever is it. And now, and as long as this is specular plane here, specular reflection, that means the angle of incidence here, which is I here, it is equal in degrees to the angle of what? Of reflection. It is equal to the angle of what? Of reflection. And this is the law of what? Of reflection of light and plane surfaces. Okay, now this incident of light, when it comes now to mirrors, plane mirrors that we are using it in bathrooms, in kitchens, and in salons, and in many things. These plane mirrors, what they do exactly, they are surfaces, or they are planed or leveled surfaces to reflecting the rays of light. So that means if you have a mirror here, this is a mirror, and you are here. So that means when the light now is coming or reflected from an object here, so the light comes from the source of light, whether it's a sun or a bulb. So when it comes to this object, it will be what? Reflected from this object towards what? Towards the mirror. Then the mirror will reflect this eye into this ray into your eye. So that means now you're gonna see this object. You're gonna see this object here on the mirror. So that means the image will be here. You're gonna see the image of this object. So that means it works now as mirror. It works as a reflection plane or surface for what? For the rays of light. So this is now rays of light incident. Just here we applied for one ray, but when for an object, too many rays are reflected from that object towards the mirror, but each one of them will go into this idea, which is that the incident angle equals what? The reflected angle. Okay, now in plane mirrors, now we're gonna see an object, an image. How this image now is formed, we understand it due to what is specular reflection. But now, what is the properties of this image? If we see here now, this one is the object. Here, this one is what is the object, and this one is the image. When we see the image of the plane mirror, whether is it the image of yourself or the image of an object or the image of anything, you're gonna see this image exactly same height of the object, same height of the object. This is number one. This is property number one. And also this image, you're gonna see it same distance from the mirror to the object. It's the same distance from the image into what? Into the mirror. So now we can agree that the properties of image, it's gonna be same height, that means same size of the object. Number one. Number two, it's gonna be same distance. It's gonna be locked like if it has the same distance behind the mirror, like the same distance of the what? Of the image in front of the mirror. So that means same height, which is same height, or you call it same what? Same size, it's the same. Then same distance. Okay, what is the third property now? Third property, it's still upright. What does it mean upright? For example, this is the top of the object and this is the bottom. You see it here, this is the top and this is what? The bottom. So that means the same direction. It's not inverted back, downwards. That means it keeps the same direction. So your head is up. So that means you're gonna see your image what? Your head is still what? Up. So that means we say that it is what? Upright. What? Upright. Okay, what is the fourth property? Fourth property, and it is the one that is different. This image, you're gonna see the left of the object. For example, now when you see yourself on the mirror, you're gonna see your right hand looked like if it is the left hand on the image. So right hand of the object will be looked like if it is the left hand of the image. And your left hand, which is the left hand of the object, we're gonna be looked like if it is the right hand of the what? Of the image. So that means because we say what? It's laterally what? Laterally inverted. Laterally what? Inverted. That means left will become right and right will become what? Left. Okay, there is one property left. So let me say I have 1, 2, 3, 4 properties. Fifth property is this image is called virtual. That means it's not like real. If it is like virtual, that means you see it like if it is on the back of the mirror, but in real, there is no back of the mirror. There is no depth there. And it is on the other side of the object. So that means the mirror is in the middle. And on one side, there is the object. And on the other side, that means it's looked like an other side. And we call this image what? Virtual image. So these ones now are the properties of images that are produced on plane mirrors. So we understand now what is reflection of light, and we understand what are the properties of images on plane mirrors, and we understand images are produced as a result of reflection in what? Of specular or small surfaces. Okay, we'll go now into another point, into the second point, which is refraction. What is refraction now? Have you wondered why we see the pencil or any object when it is inside water, we see it like if it is broken? Even the spoon or the fork or something, when you put it inside the water, you're gonna see it from outside like if it is what? Broken. Why do we see objects like if they are what? Broken? This is the refraction. And this is what we are going to understand what refraction is. Okay, what is the refraction of light? That means now the light, when it goes in straight lines from the air medium, then it goes inside the water medium, we're gonna see that the light will not keep moving in the straight line. It will be bended either left or right. So if we put here a line, that is what a straight line or imaginary line, in an imaginary normal, we call it what, the normal, and it is perpendicular to the surface here, 90 degrees, we're gonna see then this refracted light will be bended what, towards the normal. So this refraction, which is the bending of light, when it travels from medium to another transparent medium, from water into air, or from air into glass, or from glass into water, from one medium to another transparent medium, we're going to see the light itself, instead of moving in a straight line, that means it will be what? It will be bent either away or what? Or towards the normal. This property now, we call it what? Refraction. Okay, if we see now here, and this is one of the applications here. I think you have ever seen that when you are swimming, or when you swim in the sea, mainly in your eye, you're gonna see that the fish is here, which is the white one here. The white one, you're gonna see it like the fish is here. But in real, the fish is in this place. Okay, why we see the fish in virtual position? That means it's not in its real position. We see it in another one, because now what happens exactly? This is now refraction of light. How? Okay, how do we see objects? In general, how do we see objects? We see objects because the light that is coming from the sun, or from the source of light, when it goes into that object, it gets reflected to our eyes. It gets reflected to our eyes, so we see these objects. So when we see this fish now, mainly because the sun is here, and the sun rays goes into what? Into this fish here, the yellow one. Now the yellow one will reflect what? Will reflect the beam of light that comes from the sun. When it is reflected now, it will go directly here. When it goes directly here as a straight line, now there is a change in the medium, from water into what? Into air. In this case now, the light will not keep moving in a straight line. It will be bent either, as we said, towards or away of the imaginary line that is called what? Normal. So in this case, it will be bent away of the normal. So in this case, the person here, when he sees something now, he imagined that the fish is exactly where the beam of light is coming from. So that means he'll think that the beam of light is coming from this point. It's coming what? From this point, so as a straight line. So he's gonna think that this is the position or the place of the fish, while in real it is what? Here. But because of bending of light, there is what? Misunderstanding to the place of. But if you understand now, when light is coming here from the sun, and you understand now that light is bent to your eye, you can understand the fish is a little bit ahead from the position where you see it. So this one now again is refraction. What is refraction? Is bending of light when it travels from one medium to another medium. Okay, now how is this refraction, or what types of bending here, or when it will be bent towards the normal or away from the normal? If we see now this picture here, this one we said is imaginary line. This one is imaginary line, and we call it normal, and it is 90 degrees with the surface of what? Of the medium here, the two mediums. Now, when the incident angle here, this one is incident. That means incident angle, and this one is what? Is refracted what? Refracted angle. The incident angle now is mainly coming from the air. Here now, the light or the ray is coming from the air into water. From air into what? Into water. Okay, the speed of light in the air is much greater than the speed of light in water. This is number one. Speed of light in the air is faster or is higher than the speed of light in water, number one. Number two, the water has higher refractive index. Higher refractive index. I mean, I'm going to understand what's the refractive index. The refractive index is N, and it equals the speed of light in the vacuum, in the air, over the speed of light inside the water. Inside what? The water. The speed of light. And we said the speed of light here is higher than the speed of light in water. So that means numerator is greater than what? Than denominator. So that means the result is greater than what? Than 1. While N for air, so that means N for air, which is the index of refraction of air, equals what? 1. So this one here now, for water, index of refraction for water, it's going to be greater than what? Than 1. So that means now, what we understand now is this ray is coming from air to water. That means it's coming from lower index to higher index, because the water index of refraction is higher than the air. It's greater than 1. So that means now the beam of light, the ray of light, is coming from air. That means from less index of refraction medium into water, which is what? Higher index of refraction. In this case, when the light is moving from lower index of refraction medium into higher index refraction medium, in this case, the light will be refracted, will be bent towards the normal. So that means now you see it, the light here, the reflected beam here now becomes much closer to the what? To the normal. So that means now here, the angle here, angle A, which is angle of incident, is greater than what? Angle B, which is angle of what? Of refraction. When does that happen? If the light or the beam or the ray is coming from lower index refraction medium like air into higher index. So that means if the light is coming from lower index to higher index, it will go, link that, from higher angle to what? To lower angle. So what's the relationship between the angle and the index? It's inversely proportional, and keep that in mind. So that means if the light now is coming from lower index medium to higher index medium, that means it will go from higher angle and incident angle to lower what? Refracted angle. I hope you understand now. I hope you understand. So that means now this one, N here for this place now, N is low, and here N is high for this one, right? And for the angles now, for the angle, this one is high and this one is what? Is low. So that means, as you see, inversely proportional. Whereas one increases, the other one will what? Will decreases. And it's the opposite now for this image now. It's the opposite, as you see now. What about if I put here a source of light inside the water? As we know, sometimes you put lamps or torches inside the water, right? And they emit what? Lights. And when they emit lights, as you see, the light will go in a straight line, then it will be bent here away of the normal. What does that mean here? As you see, the light now is coming from water into air. So that means it's coming from higher index of refraction to lower what? Index of refraction. In this case, from higher index to lower index medium, the angle here of refraction, which is the angle between the refracted beam and the normal, will be greater than what? The incident angle. Again, if it comes from higher index to lower index, that means it will go from lower angle to higher angle. to greater angle. I hope that is clear now, because the relationship between the index of refractions of mediums and the angle of refraction is inversely proportional. Okay, how these ones are linked together now? It links to Snell's law. What is Snell's law? He said, if I call now this one, if we call this one here medium number 1, N1, so that means this one will be what? N2. And here we're going to call it theta 1, and here theta what? 2, angle 2. In this case now, he said index of refraction for medium number 1 times sine its angle, which is angle number 1, it equals what? Index of refraction for medium number 2 times sine the angle of what? Of number 2. So this one is what is called what? Snell's law. So if I have two quantities and the relationship between them is inverse, that means inversely proportional to each other, I multiply them. So I multiply now the index of refraction times sine the angle. Anyway, here now, this one, it can be rewritten in another way. I can write it here. I can take the N2 to the left side and the sine 1 to the right side. I'm going to get N1 over N2 equals sine theta 2 over sine theta 1. Or it can be written in many other things as math. So what we need to memorize now is that refraction. Refraction is bending of light when it is moving from one transparent medium into another transparent medium. And each medium has index of refraction. And index of refraction is given by the speed of light on the air, which is c, which is 3 times 10 to the power of 8, into the speed of light inside that medium. And in general, air, its transparent, its index of refraction is 1, and other mediums are greater than 1. In general, are greater than what? Than 1, because the speed of light inside other mediums will be less than the speed of light in the what? In the air. So that means in this case, index of refractions for other mediums other than the air will be greater than 1. So that means now when the light is coming from air into other another medium, in this case it goes from lower to higher index of refraction. So now if the light is coming from lower, which is air, into higher index of refraction, the beam of refraction or the refracted beam will be bent towards the normal. That means it's going to be closer to the normal. What's mean closer to the normal? That means a smaller angle now. It comes from greater angle, which is incident angle, into what? Refracted angle. And when the beam of light is coming from higher index of refraction to lower, that means from water to air, or any other examples, in this case, the refracted beam, which is this one here, will be bent away of the normal. That means it will produce higher angle than the what? Than the incident angle. This is what? Refraction. So we understand now what is refraction, and we understand what is Snell's law. Okay, what is just more other practices for refraction? Do we have, I mean, like applications of refraction in real life? We have this one, as we said, how you see things. This is one idea. And another idea, I think, when you travel, when you sometimes when you travel and it is a sunny day, usually you see the roads like this, You're gonna see it like there is water on the road, but when the car, and when you reach that point, you find what? No water there. What is this one called? It is called what? It is called mirage. It is called what? Mirage. So mirage is you see things, but in real they are not there. Okay, how do we see things? Then when you come to them, we don't find them. And how they are produced? They are produced because of what? Refraction. Okay, how do we see these things now? As we see, the light will come from the sun. The light will come from what? From the sun. And the light now, when it goes to this place now, it's gonna be reflected to our eyes. It's gonna be reflected to what? To our eyes. So since it is reflected from here, so we see this place as black place, and we understand that this is a road. This is what? Road. Okay, good. But now, At a sunny day, time, the sun will heat the particles of air that are closer to the ground. So that means when you divide here, this places into layers, layer 1, and here layer 2, 1, 2, layer 3. You're gonna see the layer that is in touch or in contact with the ground, you're gonna see that it is higher temperature. Then number 2 will be less temperature, and number 3 less as you go up. Why? Because here in this case, at this time, just because of the higher temperature of the ground, so of course the particles that they are in contact with the ground will be higher temperature. So in this case, what will happen for the beam of light that is coming from the sun now? This beam of light that is coming from the sun, what will happen with it? What will happen exactly? It will move into many refractions, gradual refractions based on the temperature. Because the temperature is different in mediums, that means the light will be refracted, that it will feel like if it's moving from one medium to another medium. So this one now, as you see, it will come here now, then it will be refracted once, then it will go here, then refracted once, then it come here, then refracted once. So when it is refracted into your eye here, it didn't move or it didn't pass into the road itself, into the ground itself. So that means it gets refracted from the air itself. So you didn't see the ground. So you see just a layer above the ground because it's reflected from above the ground. You see it like if it is reflection of what? Of the color of the sky or the color of empty space. So this one you didn't see the what? The color of the road itself. So you didn't see it here black. You see it like water. You see it like the sky. Because it's just reflection now, you're going to see it like what? As reflection of what it came from. So this one, just Mirage, is just one of the applications of refraction. So you understand now what are the properties of plane mirror images, and we understand what is refraction, and we understand reflection of light, and we understand that angle of incident equals angle of reflection for reflection. But for refraction, the angles are not the same because they go from one medium into another medium. And in this case, the angle will be different because the straight line motion of light will be bent either away or towards the normal. And I understand that if it comes from higher index to lower index, it will be bent away from the normal. And if it comes from lower index to higher index, it will be bent towards the normal. Okay, now we explain. This is for the last thing. We're going to explain what is total internal reflection, and also we're going to understand what is critical angle. Okay, if we have here, okay, we are explaining now what is critical angle and what is the total reflection. If we have here, this one here is water, and this is the level of what? Of water. If we have now a source of light that is here, a source of light that is what? That is here. And this light now is sending the ray this direction. And at this point, we have to make imaginary line, which is what? Normal. This is now the normal, and it is 90 degrees to the surface. This ray now will go like this way, and it will be bent away. It will be bent what? Away of what? Of the normal. It will be bent away of the normal, so that means it's gonna be exactly like this way. So that means, as you see, the angle here, this angle, we call it angle of what? Of incident. And this angle that is here, we call it angle of what? Of refraction. So the angle of refraction is greater than the angle of what? Of incident. Why? Because the light is coming from higher index of refraction, which is water, into the air, which is lower what? Lower index. So this is the air, and this is what? Water. Okay, now this is refraction. What happens now if we put the light here? If we put the light here, what will happen? It will go into this point, as you see, then it will be bent more, so it will be this way. Okay, now what will be this angle now for the pink one? It's gonna be angle of incident, and here, this one is what? Angle of refraction. And still, angle of refraction is greater than the angle of what? Of incident. Okay, now if we put now, we're gonna make it red here. If we make the light starting from this point, when it goes to this place now, it will be refracted exactly in the what? In the surface, or in the line that is between the two mediums, between the air and water. That means it will make now angle here that is what? 90 degrees with the normal. And at this case, we call this angle of incident. This angle of what? Of incident, we call it critical angle. We call it what? Critical angle. So what is critical angle now? Critical angle is refractive or refraction angle or incident angle. It is incident angle. Okay, what is this incident angle and why is it special? So critical angle, its definition now, is the incident angle that it will produce refracted beam or refracted ray 90 degrees with what? With the normal. Or the angle that it will produce a refracted ray that moves exactly between the two mediums like air and water. We call this one what? Critical angle. We understand what is critical angle now. Okay, if we make, and I'm gonna make it blue. If we make the light here, the source of light now here, what will happen now for the ray? It will go to this point now. And how it's gonna be refracted? In this case, it's gonna be then reflected, not refracted here. It's gonna be reflected inside the water and it will not go out. So that means when you see lamps in swimming pools or in many pools in some malls and other things, in general they put the light here on the red one, on the red place here. They put the light here, so that means you see like the surface of the water, all of it has light. So that means they put the light exactly with the critical angle of incident. This angle now, that is the blue angle here now. It represents this blue angle now. It represents when does total reflection. Total what? Reflection. So here it is what? Reflection. While here it is what? Refraction. Refraction, and here what? Reflection. So reflection, it happens when the beam or the ray of light doesn't pass from medium to another medium. It's just reflected in the same medium. So that means this blue ray here, it is reflected inside the water and it didn't pass into the air. So that means what happened to it is reflection, not refraction. Refraction when it moves, when it passes from medium to another medium. So this is now, so this total reflection now, when does it happen? Total reflection happens if the angle of incident is greater than what? Than the critical angle. So the critical angle will make refracted beam between the mediums, while when it becomes now the angle of incident greater than the critical angle, in this case, total reflection happens. And total reflection is important in many applications. One of them is our home internets now. The internets now that it comes from many companies into our homes, it moves in a narrow pipes, very narrow pipes. These pipes are, as we said, they have small diameter. They have a small diameter. And how the light, how the speed of data is moving through these ones. So when you click on a video on YouTube, that means this video now is opening from its source where it is stored, in, usually in America. So that means how it moves to the device in front of your eye as quickly as possible, and it's streaming. How? Because now the light, the data moves inside these pipes by what? By the idea of total reflection. Total reflection, that means it will go through these pipes in a speed it is around the speed of what? Of light. So that means with no time it takes, so that means it moves through these ones by the property of total reflection. Total reflection. And total reflection, we said, is when the angle of incidence is greater than the critical angle. I hope now you understand what is critical angle, what is total internal reflection, what is mirage, and what is refraction, and what is reflection, and what is Snell's law. That's it for today. And examples and questions, you find them then on the quizzes to solve them on that.